The dentations. The human dentations are usually categorized as being primary, mixed, or transitional and permanent dentations. The transition from the primary or deciduous dentition to the permanent dentition is of particular interest because of changes that may herald the onset of malocclusion and provide for its interception and correction. Onset of malocclusion and provide for its interception and correction. Thus, of importance for the practitioner are the interactions between the morphogenesis of the teeth, development of the dentition, and the growth of the craniofacial complex. Morphogenesis of the teeth, morphogenesis of the teeth, development of the dentition. It may be primary dentition, transitional dentition, or the permanent dentition, and the growth of craniofacial complex. Let's talk about the prenatal. Let's talk about the prenatal or perinatal or postnatal development. The first indication of tooth formation occurs as early as the 6th week of prenatal life. That is, the 6th week of prenatal life, you will get the evidence that the tooth is forming or not when the jaws have assumed their initial shape. However, at this time, the jaws are rather small compared with the large brain case and orbits. The lower face height is small. Lower face height is small compared with the neurocranium. You can see in the figure 2.6. In this figure 2.6 showing the neonatal skull showing large brain case and orbit. The neurocranium is larger than the splanchno-cranium, which contains the jaws and all the developing teeth. In right, the mandibular arch is larger than the maxillary arch, and the vertical dimensions of the jaws are only minimally developed. When the jaws close at this stage in the development, when the jaws close at this stage in the development of the dentition, they make contact with the tongue, which in turn makes contact with the cheeks. The shape of the prenatal head varies considerably, but the relative difference among the brain case, orbits, and the lower face height remains the same. All the stages of tooth formation fill both jaws during this stage of development. In this stage, all stages of tooth formation fill both jaws during this stage of development. Neonatal skull, if you take the brain case and orbits are relatively larger than the lower facial height. Now have a look over the development of the primary dentition. Considerable growth follows birth. Considerable growth follows birth in the neurocranium and splanchno-cranium. The splanchno-cranium will constitute the jaws and all the developing teeth. Usually at birth, no teeth are visible in the mouth. Occasionally, however, infants are born with erupted mandibular incisors. Development of both primary and permanent teeth continues in this period, and jaws and jaw growth follows the need for additional space posteriorly for additional teeth. In addition, The alveolar bone height increases to accommodate the increasing length of the teeth. However, growth of the anterior parts of the jaws is limited after about the first year of postnatal life. It is initially the jaws was post in the posterior region and in the vertical region. After first year of postnatal life, the anterior parts of the jaws growth is limited. Now have a look over the sequence of emergence of primary teeth, which is the important and most crucial part. The predominant sequence of eruption of the primary teeth in the individual jaw is central incisor A, lateral incisor B, first molar D, canine C, and second molar E, as seen in the table 2.1. This is the table 2.1. Variations in that order may be the result of reversals of central and lateral incisors, or first molar and lateral incisors, first molar and lateral incisors, or eruption of two teeth at the same times. Variations is due to reversals of central and lateral incisors, or first molar and lateral incisor, or eruption of two teeth at the same time. This subject is considered in more detail in the section on tooth formation standards and in chapter 16, which addresses the development of the primary dentition, primary occlusion, which addresses the development of the primary occlusion. Investigations of the chronology of the emergence of primary teeth in different racial and ethnic groups show considerable variation. Investigations of the chronology of the emergence of the primary teeth in different racial and ethnic groups show considerable variation, and little information is available on tooth formation in populations of non-white or non-European ancestry. Old population differences in tooth standards suggests that patterned differences may exist that in fact are not large. Tooth size, morphology, and formation are highly inheritable characteristics. Tooth size, morphology, and formation are highly inheritable characteristics. Few definitive correlations exist between primary tooth emergence and other physiological parameters such as skeletal maturation, size, and gender. Let's have a look over the emergence of the primary teeth at about 8, that is 6 to 12 months of age. The mandibular central incisors emerge through the alveolar gingiva, followed by the other anterior teeth, so that by about 13 to 16 months, all 8 primary incisors have erupted. See table 2.1. Then the first primary molars emerge by about 16 months of age and make contact with the opposing teeth several months later. Before the canines have fully erupted, Passage through the alveolar crest, you can see in the figure 2.7, occurs when approximately two-thirds of the root is formed, followed by emergences to the alveolar gingiva into the oral cavity when about three-fourths of the route is completed. The emergence data are consistent with those of Smith. This is the figure 2.7 section of the mandible in a 9-month-old infant cut through an unerupted primary canine and its permanent successor, which lies lingual and apical to it. The enamel of the primary canine crown is completed and lost because of decalcification. Root formation has begun. Right? The primary first molars emerge with the maxillary molar tending most often to erupt earlier than the mandibular first molar. The maxillary first molar will erupt earlier than the mandibular first molar. Some evidences shows a difference by gender for the first primary molars, but no answer is available for why the first molar has a different pattern of sexual dimorphism. The primary maxillary canines erupt at about 19, that is 16 to 22 months. You can see in the figure 2.8. Figure 2.8. The figure 2.8, skull of a child about 20 months of age. You can see in the picture A, view showing all incisors present and erupting canines. Right? And picture B showing the lateral view. First primary molars are in occlusion. Mandibular second molars are just emerging opposite. Mandibular second molars are just emerging opposite the already erupted maxillary molar. And the mandibular canines erupt at 20, that is 17 to 23 months. The primary second mandibular molar erupt at a mean age of 27, that is 23 to 31 for boys, 24 to 30 years for girls, months. And the primary maxillary second molar follows at a mean age of 29, that is 25 to 33 plus or minus 1 standard deviation months. In figure 2.8 A and B, the first molars are in occlusion as we have seen previously. Note this point, first primary molars are in occlusion, whereas mandibular second molars are just emerging opposite the already erupted maxillary molar.